Hello everyone, welcome to Unravel Logic channel. In today's video, we'll be talking about mean deviation. Mean deviation. Please note that this is different from standard deviation, which we'll be covering in the following videos. In addition, I am assuming that you are aware of the concept of mean, which we have covered in previous videos. If you're not aware of the concept, please feel free to go and watch my previous video first on mean and then come back to this one, because it is important that you understand mean as this concept is based on mean, based on the concept of mean. Okay. So let's start with the formal definition as usual. Formal definition. This is the measure of how far the data is scattered around a measure of central tendency, which is mean. Okay, so let me write this down. Measure of how far the data is scattered around mean. So basically this is a single representative number which will tell you how scattered the data is around mean. Okay. So single representative number telling you how far the data is spread out from the mean. Okay. Now let us try and understand this by using an example. Okay. Let us consider the time taken by two soccer teams to score the first goal in a match across 9 matches. Okay. So what we are saying is that we have two teams. We have team A and then we have team B, and these are soccer teams. Okay. So let me write it like this. Soccer teams. Okay. And we are recording the data across 9 matches. Okay. So let's say 9 matches. M1, M2, M3, M4, M5, M6, M7, M8, M9. Let us see for team A. So in match 1, team A scored their first goal at the 60-minute mark. Similarly, on match 2, they took around 55 minutes to score their first goal. In match 3, they took 50 minutes and so on. Similarly, for team B, so in match 1, team B took 70 minutes to score their first goal. In match 2, they took 30 minutes. In match 3, they took 60 minutes and so on. So we have this data with us. Now we want to analyze this data and find out some insights about both the teams. For example, which team is more mature, which team is more consistent, or which team can I rely on if I'm watching the match, right? That, for example, for which team I can make a statement that this particular team, team A or team B, would definitely score a goal by this time in a match. Okay, something like this we want to do some analysis, right? So let's start. Since we have studied mean, median, mode, right? So in this case, let's try and find out the mean and median of this data for both the teams, right? For example, on an average, at what time in a match team A would score their first goal, and similarly for B, right? And then we would calculate the median as well. Okay, so we have team A, team B. Let's calculate mean here and median here. So for both team A and B, the mean comes out to be 50, and since you can see the numbers, you can calculate it. It would be 50-50. I have already calculated it. The median would also be 50 for both the teams. Indeed, that is surprising, right? And you can clearly see that if we calculate only mean and median, we do not get much insights, right? I mean, in fact, we see that both the teams are equal. But when you see the data, you can see that there obviously is some difference between teams, between both the teams, team A and team B, which mean and median are failing to highlight. Yeah. So let us try and do some more analysis. Let's see what we can do. Let's see how we can find out which team out of both the teams is more consistent. Okay, which team we can rely on more. Okay. So in order to understand the data better, let's start by drawing the line diagram of both the teams. Okay. So let me do it for team A first, and then we do it for team B. Okay, and I will explain what a line diagram is. It's a very simple concept as such. Okay, just draw using this. Okay, this is one line. This is another line, and we simply plot some scale: 0, 10, 20, 30, 40. So these are the two lines that we have plotted along with some measurements. Okay, some measuring scale basically, and then we plot the actual data points on this line plot. Okay, so for team A, we have one point at 40, another at 45, then we have one at 50, another at 55, then we also have one at 60, and then we have another at 45, another at 50, and then another at 55, and then we have another at 50. Okay, similarly for team B, let's plot the data. So we have 10, we have 20, we have 30, 40, 50. So basically one of each, such that the mean comes out to be 50 and median is also 50. Yeah. So now you can clearly see that there is definitely some difference. You can clearly see pictorially that there is some difference between the data of both the teams, which mean and median are clearly failing to highlight. So mean and median both are 50. But let's care about mean only, since we are studying mean deviation, right? So the mean of both the data is 50, right? So what is that which mean and median are failing to tell us? Let's understand that. So if you take another look at these line plots and think about the spread of the data or how the data is scattered around the mean value. Okay, and if you think about it, you can clearly see that the data for team B deviates a lot from the mean or is more spread out around the mean. For example, if you see this data point, which is 10-minute mark, is 40 far away from 50, which is the mean, right? Similarly, if you see this 80 minutes mark, this is 30 far away from the mean value, which is 50. And you can clearly see that this is a lot of deviation. It deviates a lot from the mean. Okay, lot of sorry, I should write deviation instead of deviates. Lot of deviation. And on the other hand, if you see the data for team A or the line plot of team A, the deviation is very small, and you can see the maximum deviation that you can see is 10, which is like far more than what you see in team B's plot. Okay, and the minimum deviation that you can see is 5 or 0, I should say, right? Because we have 3 points at 50, which is 0. Here the minimum deviation is 0 and the maximum deviation that you can see is 40, right? Which is like from 10 to 50 or from 90 to 50 or from 50 to 90, right? Which is 40. So there is a lot of difference, and we can see that team B has data which is more spread out or scattered around the mean value, which is 50. So the data for team B is more spread out from the mean value, or we can say the data for team B deviates a lot from the mean value. So what does this mean, right? When we say that the data for team B deviates a lot from the mean value, what do we mean by this? What does it mean when we say that the data deviates a lot from the mean? Okay, so in the context of our example, it would mean that team B is less likely to score a goal around to score, I should say, their first goal around the 50-minute mark, which is also the mean, right? So this is what it would mean in the context of our example. Okay, but then we still haven't calculated the mean deviation yet, right? But for that we'll have to understand the mathematical formula first, but you get the concept of deviation. Okay, this is what it actually means, right? When we are trying to find the deviation, or we are trying to find how spread out the data is around mean, this is what we mean. Okay, so let's understand the mathematical formula. Okay, mathematical formula. Okay, and what we are trying to find is mean deviation, and first in line is deviation. So we need to calculate the deviation first. Calculate deviation first. Calculate mean of deviations second. Okay, so you already know how to calculate mean, right? It's very simple. So first we calculate the deviation of each data from the mean, and then we'll calculate the mean of all those deviations, right? Which is summing all those deviations and divided by the number of deviations that we have calculated. As simple as that, right? So when I say we'll first calculate the deviation of the data from the mean, what I actually mean is the difference, right? How far the data point lies from the mean. So we subtract that data point from the mean, right? And we do this for all the data points, and then we sum it, and then we divide by the number of data points. So that would be mean deviation, as simple as that. So let's go ahead and see what it means. Okay, how to calculate the deviations. Let us do it for team B. Okay, so let me plot the team B once again. Okay, now we calculate the deviations. So deviation is nothing but difference of the data point from the mean. So the data point at 10-minute mark is like 40 minutes away from the mean. This is 30, this is 20, this is 10, this is 0, no deviation. Then this is minus 10, this is minus 20, minus 30, minus 40. Now since we are talking about the deviations, right, we are not really concerned about in which direction the deviation lies. For example, the sign of the difference, right, which is this minus 10, minus 20, minus 30, minus 40. So we would actually remove the sign. We won't really consider the sign because it doesn't really matter. Okay, we just need to know how far the data point is, right? It doesn't really matter whether it's positive or negative. So let's make it 10, 20, 30, 40. Now that we have the deviations, we need to find the mean of the deviations, right? So what we'll do is 40 plus 30 plus 20 10 plus the, I will skip the 0 here. 20 plus 30 plus 40 divided by the total number of data points. So the total number of data points we have are 9 because we measured across the 9 matches. Okay, so I just didn't write the 0, but the 0 would really matter because we are counting the total number of matches, which is 9. Okay, so this would come to 22.2. Okay, so this is the mean deviation for team B. So this is what the formula would look like. So we have MD, mean deviation of X bar, is equal to summation of the differences of data point from the mean, which is xi minus x bar over n. Okay, and if you see, this is x bar or mean. Okay, this is sum, and then this is data point, this is absolute, nothing but ignoring the sign. Then number of values. Okay, here we can also write where I is equal to 1 to n. Okay, where in our case I is m1, m2, m3, which is nothing but match 1, match 2, match 3. So this 1, 2 and 3 are the values of I. Okay, understood? So that is the mathematical formula for mean deviation. Now back to our example, right? If you calculate the mean deviation of team A, MD of x bar of A, then it would come to 4.4. Okay, so you can clearly see that mean deviation for team B was 22.2. So MD of x bar of B was 22.2. You can clearly see that the mean deviation of team A is very smaller than the mean deviation of team B. So what does it tells us, right? In the context of our example, and it will always be interpreted in the context of your requirement, right, or whatever problem that you are trying to solve, right? In our case, what we wanted to identify is that which of the teams is more reliable. Okay, so you can see that mean deviation of team B is 22.2, which is more than the mean deviation of team A, which means that for team B, whenever they are scoring their first goal, right, there is no guarantee that at what time or what time in the game that they are most likely to score their first goal, right? That is what the mean deviation of team B tells us, because what we have observed in our data collected so far is that the data is very spread out from the mean value, right? Although the mean says that the team B will score their first goal at 50-minute mark, but when you analyze the mean deviation, it tells a different story. It tells that the data is more spread out and they can score a goal at 10-minute mark, they can also score a goal at 90-minute mark. There is no consistency. But when you see the mean deviation of team A, which is 4.4, which is way smaller than the mean deviation of team B, in comparison, you can say that the data points of team A are more closely scattered around the mean. Okay, more closely scattered. They are not far from the mean. So when you say that the mean value is 50, you can be rest assured that team A would most likely score their first goal around 50-minute mark. It can be 55, it can be 40, it can be 45, but it won't be 10 most likely. Okay, it won't be 90 most likely. It will be somewhere close around 50-minute mark. That is what the mean deviation tells us. So I'm sorry, this is the mathematical intuition, right, behind calculating the mean deviation. Right? So based on the context of your requirement, based on the context of your problem, based on the context of your analysis, you would understand what this number means. Okay. interpret based on your based on the context of your problem requirement or analysis. Okay. So there are no advantages or disadvantages of a mean deviation as such. It is something that you should calculate along with median and mean, so that you know that you can make sure that the mean and median are not deceiving you as they did in our example. Okay. So a mean deviation in most cases would always give you more insight. So it's actually that's an advantage actually, right? But there are no disadvantages as such of calculating mean deviation. Yeah. So yeah, that's it for mean deviation. Thank you for watching. Please like, share, and subscribe for more such content in future. Thank you.